Okay, first of all, I want to thank you, the Aspetar, for giving me this opportunity to come to Doha and present some of my work. I would like to welcome you to my talk about training alters fatigue patterns during exercise. We were interested in investigating the influence of training as well as hypoxia on fatigue development. What is the influence on oxygen deficiency and peripheral fatigue? So here we see that in this study they had to perform a constant load and constant duration exercise, and as we see, the greatest development of peripheral fatigue was seen under hypoxic condition or in hypoxic conditions. In this study, in the above one, we see the absolute values of evoked quadriceps twitch force from pre to post testing, and we've seen here they had to perform a constant load exercise, but this time it was with an open end, so till exhaustion. And we see, again, high development of peripheral fatigue under hypoxic conditions, but the same was seen under normoxic conditions, whereas it wasn't seen in the control, or there was a higher development here. The control was also constant load, but the time was adjusted to the time of the hypoxic trial. Below, we see central fatigue, and the voluntary activation, again, decreased the most in the hypoxic trial, whereas there was less decrease in the control as well as under normoxic conditions. So what was our hypothesis? Our hypothesis was that normoxic training evokes changes in peripheral fatigue pattern, whereas a hypoxic training predominantly elicits changes in central fatigue. Now to the study setup. What did we perform? We had 16 untrained healthy subjects. They had an average age of 28 years. And we were asked them to perform a maximal incremental exercise test as well as a time trial test. With the time trial test, they were given relative to their achieved power output or work in the maximal incremental exercise, they were given a work which they had to complete as fast as possible. And both tests were performed under normoxic and under hypoxic conditions. Then they did a training intervention which was double-blinded, and half of the group trained under hypoxic conditions, the other half under normoxic conditions. To assess peripheral and central fatigue, we used the magnetic femoral nerve stimulation, which was already explained by Professor Amon. And for the peripheral fatigue, we looked at the potentiated twitch force and compared it from pre to post testing, and the reduction in twitch force then indicated a development of peripheral fatigue. For to assess voluntary activation, we used the twitch interpolation technique. Now to give you an overview of the whole study. So we first assessed the fatigue development, then they were put on the bike, they performed the maximal incremental exercise test. Immediately after, again, we assessed fatigue, and then they had an hour rest, and the same started again. We did femoral nerve stimulation, then they performed their time trial, and again, immediately after, peripheral or fatigue patterns were assessed. To give you an overview of the whole study, both tests were first performed under normoxic and under hypoxic conditions. This was then followed by double-blinded, standardized endurance training for 6 weeks. They trained on every second day for an hour. And again, after the training intervention, the same tests as before the intervention were repeated. Now to the results from the maximal incremental exercise test. I first guide you through how the graphs are set up. Gray is always representing pre-training, post-training is the black bar. And on the x-axis, we see on the left the normoxic testing, so the tests that were performed under normoxic testing conditions, on the right under hypoxic testing conditions. Nor representing the normoxic training group and hypoxic training group. Here we show the maximal power output from their maximal incremental exercise test, and we see that after training, they were able to significantly increase the power output. Same was seen in the hypoxic training group, and also the similar pattern under hypoxic testing conditions in both training groups. If you look at the maximal oxygen uptake, we again see that they were all able to increase their VO2 max, except only the normoxic training group significantly increased their VO2 max in both testing conditions. If we look at the time trial performance, again on the y-axis with the average power output over the whole training time trial test. And we see again they were all able to significantly increase their average power. On the right, we see the time. So the time it took them to complete the given work. And again, it took them way longer from pre-training compared to post-training, where they all were able to significantly decrease their time to exhaustion or to finish or complete the time trial. Now to the data, the peripheral fatigue data. On the left, we have the data from the maximal incremental exercise test, the percent change of quadricep twitch force compared from pre to post testing. And we see that from pre to post testing, they all significantly fatigued. So they all developed a significant peripheral fatigue. If we now look at the influence of training, we see that only in the hypoxic training group under normoxic testing condition, you can see a decrease in peripheral fatigue. If we pool the data from the normoxic testing condition together, doing a mixed model analysis, we see that training has a significant effect, whereas under hypoxic testing conditions, there was no effect observed. If we now move on to the time trial test, we see a similar pattern. First of all, they all, again, fatigue, except two of them, they were close to significant. And again, looking at the influence of training, we see that there's a close significance, again, in the hypoxic testing condition, training group under normoxic testing condition. And again, pooling the data together, training has a significant effect under normoxic testing condition. If we now look at the central fatigue, in general, changes were rather small. And the only significant development of central fatigue was seen under hypoxic testing conditions in both tests. Here, it was seen in the hypoxic training group, over here in the normoxic training group. If we look at the influence of training, although the changes were small, we only see in the maximal incremental exercise test that the training had an influence, a significant influence. But all in all, changes were small. Now, already come to the conclusion. In general, we've seen that the subjects were all able to increase their performance in the incremental exercise test and in the time trial test. If you look at peripheral fatigue development, we've seen that there was a decrease in peripheral fatigue under normoxic conditions, whereas we haven't seen any changes from pre to post training in the hypoxic testing conditions. But in general, changes were small. If you look at central fatigue, again, changes were rather small, but we've seen, the only change we've seen was an increase in central fatigue. Overall, the data that there was a significant influence of training, but only in the maximal incremental exercise test. In general, as we've seen comparing hypoxic to normoxic training, we've seen that hypoxic training didn't give an additional value to the performance. Is it in performing under hypoxic or under normoxic conditions? Now I'd like to thank you for your attention and all the researchers that support me, Carsten Lumpy, Martin Wolf, etc. Thank you.
If the audience has any questions, Daniela, do you want to just come down the front here? That's fine.
Great study, Daniela. The only problem that I see with that study is that you compare time trial performance, or that you use time trial performance to keep these people.
Mm-hmm.
So, the training had an effect in terms of the power output. So the amount of work that was done after training is always greater than before training. So when you want to know what a certain training regime does to fatigue resistance,
Mm-hmm.
you have to make sure that you challenge them the same way. And in your case, you challenge them in a different way.
Yeah.
Do you have a response to that?
Well, I guess we could do the same again and then stimulate them when they've done 300 watts and kind of at the same workload. Yeah. To get same time, and compare what the response is there after training, so we can definitely needs to be improved.
Okay, one very quick question, please, and then we will. Yes, Chris.
Daniela, very interesting. Can I ask? I'm sure you did so. How well did your blinding work? Did you ask the question?
Yeah, we did a questionnaire, and actually they didn't know at all. It was most of them that train in hypoxia. They said they were training in normoxia. Yeah. So.
Okay, thank you, Daniela.
Thank you.